You might not see it, but you probably use it every single day. I'm talking about a programming language that powers everything from these massive corporate systems to the smartphone right in your pocket. It's Java. And for decades, it's been an absolute powerhouse, a real cornerstone of our digital world. So let's dive in and find out why. Seriously, ever stop and wonder what makes your Android phone just work? Or how giant companies run their most critical software? Or maybe what builds that amazing, blocky world of Minecraft? Well, the answer to all of those, in large part, is Java. And believe me, its popularity is no accident. It was built on a truly revolutionary idea. So what is Java really? Let's get right into it and break down the core concepts. Okay, so at its heart, Java is what we call a high-level language. All that means is it's written in a way that's much closer to human language than that raw, confusing machine code. It's also object-oriented, which is just a fancy way of saying it organizes code into these neat, reusable blueprints. But you know what? Its real secret sauce, the thing that made it famous, is that it's both compiled and interpreted, a kind of hybrid approach that makes its most famous feature possible. And that feature, it's captured in this one iconic phrase, write once, run anywhere. I mean, that was the game-changing idea behind Java. You write your program just one time, and it should just work. On a Windows PC, on a Mac, on a Linux server, even on a mobile device, without having to change a single line of code. So, how does Java actually pull this off? I promise you it's not magic. It's a really clever two-step process. Let's take a look at how it works. I mean, really think about it for a second. Different computers, different operating systems, they all speak fundamentally different languages at their core. So how can one single program work on all of them? Well, the secret lies in a middleman. So here's the breakdown. First, you write your Java code, the stuff that's easy for us humans to read. Then, the Java compiler gets to work. But here's the key. It doesn't turn it into machine code for one specific computer. Instead, it creates this universal, intermediate language called bytecode. Now, this bytecode can't run by itself, but it's understood by a very special kind of translator. And that translator is the Java Virtual Machine, or JVM for short. See, you install a different JVM for each kind of operating system. There's one for Windows, one for Mac, and so on. The JVM's job is to take that universal bytecode and translate it right on the fly into the native language that that specific computer understands. That, right there, is the secret behind write once, run anywhere. Pretty clever, right? Okay, so that's the big high-level idea. Now, let's roll up our sleeves and actually see what this code looks like. And we're going to start with the classic first step for pretty much any programmer. And here it is, Hello World, the simple little program that just prints that phrase to the screen. Now, I know, it might look a little intimidating with all those special words and curly braces, but trust me, this basic structure, a class that holds a main method, is the starting point, the blueprint for every single Java application you'll ever see. So that main method line, that's the official front door to your program. It's the entry point. The keywords public and static, you can basically think of those as telling the JVM, hey, this door is unlocked and you don't need a special key to open it. That makes it super easy for the system to start the program. And the word void, that just means that when the program is all done, it doesn't need to report anything back. Simple as that. All right, so now that we've seen the basic structure, let's look at the fundamental building blocks that you'll use inside your programs to actually handle information. In Java, all your information gets stored in things called variables. The most basic ones are called primitive types. Think of them as simple containers. They handle stuff like numbers. You've got int for whole numbers and double for decimals, single letters or symbols with char, and simple true or false values with Boolean. And here's what that looks like in actual code. It's really straightforward. You just declare the type of container you want, give your variable a name, and then you assign it a value. So for example, int myInt equals 100 just creates a little box named myInt that holds the number 100. This is how you fundamentally store and manage information in your programs. But, a program is so much more than just a list of data. Its real power comes from being able to make decisions and repeat actions based on that data. And we call this control flow. To make decisions, you've really got two main tools in your belt. The if-else statement is your classic choice maker. It's like a fork in the road. If this condition is true, go left. Otherwise, go right. Now, for situations where you have a whole bunch of possible choices, The switch statement can be a much cleaner way to go. It just checks a variable against a list of options and runs the code for the one that matches. And for repeating actions, you have loops. A for loop is absolutely perfect when you know exactly how many times you need to do something, like process these 10 photos. A while loop, on the other hand, is for when you don't know. It just keeps on repeating as long as a certain condition is true, kind of like keep checking for new messages until the user closes the app. So, there you have it. From that huge vision of write once, run anywhere, all the way down to the simple logic of an if statement, you've now seen the real building blocks of Java. It's a language that gives you a powerful toolkit to create, to solve problems, and to build just about anything you can imagine. The only question left is, what would you build first?